Good morning. Welcome to episode number 42 of the ZOOMTOWN experiment. We're picking right up from where we left off last week, talking about sweeping turns and talking about pivot turns. And that was all in preparation to get us to today's subject, which is pulling into the driveway and backing out of the driveway. That's going to be a very critical maneuver because we literally start every trip in ZOOMTOWN in a driveway and we go to another driveway. So it's a very popular maneuver that we have to get mastered very well. The programming structure, all that's the same as it was as we showed last week, so we'll kind of focus more on the maneuvers, and we'll also want to walk you through just an outline of what we're going to cover so that you can follow along a little more easily. Dealing with driveways. All trips will start in a driveway and end at a driveway. Thus, there's a lot of pulling into driveways and backing out of them. Pulling in requires a pivot turn, then line following into the driveway. Backing out requires a blind straight line move followed by a pivot turn. We cannot perform line following in reverse, which makes the previous step, backing out is blind, a little more tricky, but so far it's actually been working. And finally, encoder feedback and the distance sensor, our CAS sensor as I've been calling it, collision avoidance system, are both used for positioning going into and backing out of the driveway so that we have a better localization and a better position tracking so that when we get in we don't hit the garage door, so to speak, and backing out we don't drive off the end of the world and fall down, because in truth ZOOMTOWN is a flat earth, so to speak. Let's go ahead and we'll demonstrate the run that we've got here going around. This is very much the same code as last time, except for this time, hopefully the Zoomie is pulling into and backing out of driveways. That is another excellent demonstration of the position tracking and the precision that we're getting out of this new system. So far, as it just keeps working, haven't really done a lot of tweaking to it. In fact, some of the numbers I'm throwing at it are not actually accurate numbers. I'm just kind of grabbing numbers such as driveway positions. I won't say randomly, but they're close but not perfect numbers. And that's just a secondary test in this to see if it behaves better or worse or what could possibly go wrong, right? So we can see that the Zoomie can get in and out of the driveway and get back to the proper traffic lane and get going in the right heading, and as well as pull into the driveway and not hit the garage door. So let's take a look at a couple areas in the code to see how this is working and how it's happening. We will go all the way down where, again, the trip plan is created. Re-emphasize, this will change, and it's already in the process of changing, and I'm making it more complicated but more useful. And this data gets sent from the scheduler computer, which, by the way, this is actually the scheduler computer. and it is running. That's the software right now. I'm testing out some other functionality with it in parallel to what I'm developing here. Now, this data gets sent into the Zoomie. Once it receives it, it'll start processing it and go about driving around ZOOMTOWN. The biggest changes I'm adding to it have to do with localization and communicating data from the Zoomie to the scheduler and the scheduler back to the Zoomie. But the rest of this is all pretty much the same stuff, except for this is driving around through the middle of the town. And here we are. These are the commands. Let me highlight that. PID, pull into driveway. BOD, back out of driveway. There is a difference in that positioning, and I'm still tweaking that because one, I'm not fully sure of why I've got 0.3, which would be, we'll call it 8 millimeters of differential there. But I'm going to keep tweaking on that. And again, that'll be data coming from the scheduler. It's not hard-coded in normally into the Zoomie code. But we're going to pull into the driveway. And because we're going from the far lane, we're turning left, so we got to cross the opposite traffic lane. Remember, this is the US, we're right-hand driving. That's why you'll see 8.5 and 8-inch, 8.5 and 8.2 inches in this program. And then at the end, when I demonstrate the right turn, it's going from near lane into the driveway. So it's essentially 4 inches less. But these are the commands. We're going to select one or the other to go in or out and give it a distance to go. And that's pretty much it. So that gets processed while the whole program is running. And then every time a motion ends, this routine will be activated, and that'll set the motion parameters to perform that motion. And that was what we covered. Pull into driveway. This is the parameters that are needed. Most of these are all our normal parameters as far as getting a motion going. If there's turning, we got to have ratios set up. This may actually be obsoleted now. But what is new, you'll see these two here. Cast distance, transition state. Right now, this is, think of this as a flag. Once I transition, as the Zoomie's moving into the driveway, I keep tracking how close I am with the cast sensor. The cast sensor will have a trigger point. That trigger point is what I use then to set the absolute position for how much further, and that in turn works in how much further we need to move and stop short, just short of hitting the garage door. So that's unique to this motion. We'll also use it in backing out of driveway. We're turning on line following. We're establishing the distance. That's coming in parameter 1 from that previous section. We establish our travel distance related to left and right wheels, distance to go for left and right wheels. We set our motion velocity. We turn on the motion status, meaning we're in the movement, as opposed to STP for stopped. Once that gets going, we'll do this a little different this time. Down here, in our main loop, this is executing. As soon as it sees PID, it'll start executing this function. It won't be performing these other ones. So PID, pull into driveway. So now that function would run, and that is up here. Pivot turn right, pivot turn left, back out of driveway, and this must be pull into driveway. A whole bunch of global variables again. As mentioned in the last video, that's almost all to do with position tracking, and that'll be enhanced even more as that gets further refined. Here is our line following, just as we do on a lot of the other movements. When we pull into the driveway, you'll notice that I have added these longer lines here for line following. I don't need the darker gray or anything like that. Just having the white line there worked out more than well enough for the Zoomie to find it and then follow it into the driveway. This is the first phase of it, where as we're moving in, we're going to get that trigger distance, cast distance less than 2, and the transition state flag is still equal to 3. I think those are minus signs, not underscores. Once we are at that point, then this gets flagged here so that the next code segment could run. But we're just adding in our absolute marker and updating that, or not adding it in, just updating it at this time, and then setting the flag. Once that flag is set, we're now within 2 inches or 50 millimeters of the barrier, and so now we're tracking it using absolute position coordinates and doing our test here to make sure that we're greater than the forced marker, the one that we preset in the routine defining the motion variables. We're checking to see if either the left or the right is beyond that, greater than or equal to that, and should it be true, then we'll flag it as motion stop. And that's pretty much it. We'll go down and find our back out of driveway, how we prepare for that in our set MVC parameters. PID, back out of driveway. Cast state, we're going to turn the collision avoidance system off for the moment. We've got, because right now it's the cast sensor sees that we're right up against the garage door, so it's just going to be flagging constantly, oh no, we crashed, or we're crashing. So we turn it off, set our basic parameters for motion, get our distance to move from parameter 1, get our left and right settings for distance to go and distance to travel. We're going in reverse, we're backing out of the driveway. We reset our 0 positions, like we do on every start, set our velocity, and right now I'm sleeping a half a second. I'm doing a debugging operation here, trying to figure it out. I think I found the problem, but normally we wouldn't do that. Turn the motion on, down below, just as we did with the other stuff. Back out of driveway. Now we're going to run this function instead of the others. Come back up to here and get to... Here's our back out of driveway function. You'll notice that we're not doing line following in this function. Line following in reverse in this mechanical configuration simply does not perform good at all. It's been a disaster. And you tinker around with it enough and it kind of becomes very easy to understand why. But what we're going to do is establish our distance to go so that we have an endpoint. We'll average that out. We'll calculate our error based on where we are and how far we got to go. We're going to use a proportional adjustment on that. And then we'll adjust the 2 velocities to steer it based on encoder feedback as opposed to the TCRT 5000 sensors reading the line. And then finally, we will update the desired run velocity and then adjust it. And as we're backing out, we'll check our distance on our cast sensor, and the average distance being less than 1, we've backed up far enough, so then we'll stop the motion with the motion status STP. And then that would get us to trigger the next thing that has to be performed, and that would be our pivot turn. up here, I wanted to show you that flag. And right here, you'll see is cast state active. Then I can perform the triggering for whether or not the Zoomie should stop, and that's handled in another routine, I believe the decel routine. So that's why we disable it. But just to keep it straight, when we pull into the driveway, we're doing line following and the cast sensor and encoders to figure out how close to the garage door we get. When we're backing out of the driveway, we are going to use encoder steering, not line follow steering, and we will also use the cast sensor and the encoders to figure out how far to pull out so that we get lined up with the correct traffic lane. So that should cover the code for it. So what I think I will do, I will call up the opposite direction so we see the behavior of that, and then we'll give that a test run. The code for that is pretty much the same. I don't even think there's really much to talk about that is different once we get down to here, because the code is the same, the logic is the same, it's just the data in the trip plan that tells us which way to go and in which path to follow. And here is our pull into the driveway, back out of the driveway, still that same 0.3 inch differential, but now you'll notice we're only going 4 instead of 8 inches, and that's the difference between the two traffic lanes. So with that, I will get it positioned. And we will give it a go, and hopefully nothing falls off the end of the road. And that is right turning into the driveways. All around, as I keep mentioning, I've been very fortunate in that our position tracking and all that is behaving really good, and I'm hoping it continues that way, because that will simplify a lot of our movement forward as we progress into the next phases of testing. Now, as you can see, a lot of this is starting to come together where I'm going to have to rely on the scheduler up over there and the scheduler computer. So I got to kind of do double duty programming here. The scheduler still requires a substantial amount of code for it. So it might be intermittent in how often I can post on this as these different elements come together. Now, as far as what I'm going to cover next, I need to do about 3 things, almost all one right after the other or simultaneously, along with further develop the code over on the scheduler. So I'm not exactly sure which topics will be next, but here are things that I have to do very, very soon. I need to get the global XY positioning functional in the ZOOMTOWN layout right now. I've got to get that, because that is what I'll send to the scheduler, which is looking at basic XY coordinates relative to the origin that I pick, and most probably that'll be in the upper left-hand corner of ZOOMTOWN. So I'll be passing that to the scheduler. The scheduler then can move the icon of each Zoomie to where it is in relationship to that coordinate data. So it should be graphing live over there as well on this one. I need to get that part functioning. I need to get a few more things tied up in the code here. There's little bugs, as I've mentioned. I need to focus on those to try to either ensure that I've already fixed them, or that they can be fixed if I learn a little more information about why they're behaving that way. We also need to get the communication going, so MQTT now becomes actually importantly functional, so I've got to implement that and get that going between the two. I think most of the motions are pretty well set. There's still one I haven't explained, not a real big issue to worry about. It's just a continuation line, and I think that'll make more sense once the trip plan is completed and how we're processing that. And then I'll explain how that actually operates in a little more detail, how we get the data, process it, which I've been showing, and then how the executor will run it and so forth, and how important that'll be. So it's going to be kind of a crazy couple of weeks coming up, and hopefully it'll be getting a little more exciting as we get closer and closer to the ZOOMTOWN experiment, moving into the phase of what it's been all about, to see if I can get 16 Zoomies to all move around on the layout without hitting each other and as autonomously as possible. So that'll wrap this one up. Thanks for watching, and I look forward to seeing you next week.